In this video, I'm going to solve the problem 23rd from chapter 19, and this time I'm going to solve the three subdivision G, H and I. Figure shows a cycle undergone by 2 mole of an ideal monoatomic gas. The temperatures are T1 equal to 300 Kelvin and T2 equal to 600 Kelvin and T3 equal to 455 Kelvin. And this time we are going to consider the state from 3 to 1. So you have to see the arrow mark in the figure, which is moved from the point 3 to 1. And for this state, we are going to find what is the heat energy transferred, what is the change in internal energy, and what is the work done by the gas. So this time, which state we are going to use? We are going to use the state 3 to 1. And let's rewrite what is given in the question. The number of moles here they mention as 2 moles, and the temperature T1 300 Kelvin and T2 600 Kelvin and T3 is 455 Kelvin, right? And here the gas is a monoatomic gas. What's the gas? It's a monoatomic gas. Okay. Now you have to see the figure. So we have to identify what is the process taken place in this figure. So from the point 3 to 1, because we are going to consider the state from 3 to 1. So if you see this state 3 to 1, which takes place, you have to see the x-axis, the volume change. That means if the volume is changing means the process is under constant pressure. As we already studied this information in the theory class. So whenever there is a change in volume, so the process is at constant pressure. So what's the process here? The process here is at constant pressure. Clear? Okay. And for this, we are going to find what is the heat energy transfer. So let's start. So this time I'm going to solve the G part. So I'm going to find the answer for the G part, amount of heat energy transfer. So Q equal to at constant pressure, we have the rule NCP delta T, right? And Cp for the monoatomic gas, which takes the value of 5 over 2 times R. And here the temperature we are considered from the state 3 to 1. So you have to see the figure from 3 to 1 means this is the initial, this is the final. So that means T3 is initial and T1 is final. So when you go for change in temperature, it is T1 minus T3. Clear? Because T1 here is the final. So I am going to substitute the Cp value and the temperature here. So by that the above expression will become N multiplied with 5 over 2 times R multiplied with T1 minus T3. Why T1 minus T3? Because this time we are going to consider the state 3 to 1. Now I am going to substitute the value. The number of moles of gas is 2 mole multiply 5 over 2 times, and the gas constant is 8.314. And the temperature T1 is 300, as we already read the question, am I right? So temperature T1 takes the value of 300. So if you want, you can just have a look here. T1 is 300 Kelvin and T3 is 455 Kelvin. Now I'm going to calculate. Let's see what is the answer for the heat energy transfer. So I got the answer as minus 6.440 multiply 10 power 3 joules. So this is the answer for this part. Clear? Okay. Now I have to answer for the H part, the change in internal energy. The change in internal energy takes the rule N CV delta T, right? And the CV for the monoatomic gas is 3 over 2 times R. And again, the temperature, change in temperature is T1 minus T3. So I have to substitute the value of CV for the monoatomic, which is 3 over 2 times R. So I'm going to take the value of CV and I'm going to substitute here. And also I'm going to substitute the value of change in temperature. By that, the above expression will become N multiplied by 3 over 2 times R multiplied with T1 minus T3. So now I'm going to substitute the value. N takes the value 2 multiplied by 3 over 2 times R, which is 8.314 multiply, and T1 takes the value 300 minus 455. So what's the answer for this? I got the answer for the change in internal energy is equal to minus 3.864 multiply 10 power plus 3 joules. So this is the answer for this part. Clear? So now we have to answer, I think third part, I think we have to answer for the work done, right? Okay, I part, so which is work done. I. We are going to find the answer for work done. So what is the work done? I have to write the first law of thermodynamics as we already studied. What is the thermodynamics? First law of thermodynamics. It says amount of heat energy supplied to the gas, which is equal to the change in internal energy plus work done. So this time we are going to find the work done. So I have to rearrange this equation in terms of work done. So therefore work done, which is equal to Q minus. So when you just move this change in internal energy to the left hand side, it will take the negative sign. So Q minus change in internal energy. And here we have the answer for Q and change in internal energy in part G and H. So G part we have minus 6.440 10 power 3, and the change in internal energy value we got minus 3.864. I'm going to substitute the value here for getting the answer for the work done. So let's see what is the answer. So work done, which is equal to Q takes the value minus 6.440 multiplied by 10 power 3 minus, and here the change in internal energy again minus, so I have to write minus 3.864 multiply 10 power 3. So let me see what is the answer. So when you multiply minus into minus, it becomes plus. So we have to do the calculation for getting the answer for the work done. So I got the answer for the work done as minus 2.576 multiply 10 power 3 joules. So this is the answer for the I part. Clear? That's it. Thank you.